Hi guys, so as with any lesson, I always start with our prior knowledge with our students, discussing our different properties like the identity property, the inverse property, the associative property. And so with identity, talking about that for addition, our identity is 0. For multiplication, our identity is 1. With the identity, when we perform this operation, it gives the same result as that went in. So 7 plus 0 is 7. So when we add the identity to a number, we do not change our outcome. Same with multiplication. When I multiply 7 by 1, I do not change my outcome, but get 7. For inverse, the inverse is always when we multiply or add by the inverse, we know we're going to get out our identity. So for addition, it's like adding the opposite. So if I have 7 here, the opposite is -7. If we add 7 and -7, we will make a 0 pair, which is exactly what we wanted as the identity is 0. When we multiply by the inverse or the reciprocal, so we have a number 2/3, its inverse is 3/2. When we multiply 2/3 and 3/2, we're going to equal our identity, which is 1, and make a 1 pair. And then lastly, we have the associative property, and so we have addition. If I add 3 and 1 and then add 2, I'll get the same answer as if I added 2 and 3, then added 1. Same with multiplication. If I multiplied 3 and 1 and then multiplied 2, I'd get the same answer as if I multiplied 2 and 3 and then multiplied 1. We could also talk about the commutative property with our students, and that if we added 2 plus 3, it's the same as adding 3 plus 2, which we could use then when talking about composite functions. After discussing the different properties we'll need to know, I would start working with our students to find an inverse. So when we have a function v of x, in order to find the inverse, we have to first talk about what's going on in v of x. So we want to start with our operations of v of x. So if we look here, we have a function v of x, and so that means we're taking this number x and we're doing different things to it. So first, if we look and see, we start with x cubed, so we're taking a number and then we're going to cube it. After I cube that number, I'm going to multiply by 2, and that's where we have this 2 times x to the third. Last, we'll take that new number we made after multiplying by 2, and we're going to add -7. And so if we bring this down, we have our number 2x to the third, and I'm going to add -7. So to find the inverse, we're going to take what we did and work backwards. Here I added by -7, so I'm actually going to add the opposite. So we're going to start by taking a number and adding 7. Next, I'm going to take that, and originally we multiplied by 2, so let's multiply by the inverse. And multiply by 1/2. So I'm taking that x plus 7, and I'm going to multiply by 1/2. And then lastly, we cubed a number, and so what we're going to do is take the cube root. Now, I wrote this within power here of a fraction. We could do this, or we could also write it using a radical with an index of 3. And so we take that, slide this up, and so we could also write it this way. So now that we have this function z of x, we need to talk about what we could do with this. So first, we're going to take a step away from the problem of v of x and z of x, and we're just going to talk about composition of functions in a general sense. If we have two functions, f of x and g of x, both of these functions are functions in terms of x, but now what we're actually going to do is, so for f of g of x, instead of doing f of x, I'm doing f of g of x. So I'm taking this function g of x and I'm going to put it into the equation f of x, then we're going to simplify. Now for g of x, it's going to be exactly the same but reversed. So we're taking f of x and filling in to the g of x, the g function, and so now it's g of f of x. We'll simplify that as well. After you simplify both of these, if they are equal to each other, which will be equal to x, which is actually our identity for functions, then f of x and g of x are inverses, and this here is the commutative property, saying that no matter which way we go, we're going to get the same outcome, which is not always true for the composition of functions, but if they are inverses, it will be true. So now we went here and we already figured out our inverse. You know, we have our function v of x, and then we found this z of x. But are they inverses of each other? And so what we want to do is we have our v of x and our z of x, but what we want to do is find v of z of x and z of v of x and see what they equal. So we're going to start here with v of z of x. So I'm going to take my function v that we see here, and every time I see my x, I'm going to replace it with this function z of x. And so now we have this nice function here. But let's simplify this. So I have to the third power and to the 1/3 power, or taking a cube of something and then cubing it, and we know that those are inverses, so we can simplify it down here. And we can simplify it down here. So I have 2 times x plus 7, which is being divided by 2, minus 7. Well, when we have something in its division, we know that that's the inverse operation of multiplication, and so we're going to rewrite this. And so here, now we have 2 times a half times x plus 7 minus 7. Well, if we recall, 2 and 1/2 are reciprocals, which means that when we multiply them, they are going to give us our identity, which is 1, because they are inverses. So 2 times 1 1/2 is going to give us 1. So now we're here with 1 times x plus 7 minus 7. We're multiplying x plus 7 by 1. Well, this is the identity. We know it does not change our outcome. So if I multiply something by 1, I'm going to get the same thing back. And so we know here that x plus 7 minus 7 is equivalent. Well, now let's talk, because we have this plus 7 and this, and then we're adding negative 7, and so we know that these are inverses of each other because I'm adding the opposite, and so that these make a 0 pair, which we have here. So now I have x plus 0. Well, once again, 0 is our identity. I know that if I add a number plus the identity, it's not going to change our outcome, and so we know that x plus 0 is equivalent to just x. So now we can say that v of z of x is equal to x, which is great because that could mean that this is the inverse, as long as the same thing is going to work over here. So let's check and see, and let's see if we can move this a little differently so we don't keep scrolling up. But if we look here, or if we just, let's extend this, it should help us a little bit. So here we have z of v of x. So now I'm going to start with this function here, and where I have this x, instead of writing x, we're going to replace it with our function from v. And so now we actually are going to end up with this nice function here, but we need to simplify it. So let's start on the inside of our parentheses. We have here a negative 7 plus 7. Well, these are inverses of each other. They are opposites, and they make 0. And so we could simplify this here to say that 2x to the third plus 0 is equivalent. And if we look, that was our last step in the first problem, and now it's our first step in the new problem. And so if we see, we're kind of working backwards of each other because they are opposites or inverses. Well, so we hope, and we hope that this works out. So now here I have 2x to the third, and I'm going to add the identity by adding 0. Well, we know if I take a number and add the identity, we're not changing the outcome, and so 2x to the third would be equivalent. Well, now we're going to rewrite this here, and so we know that this is equivalent of writing 1/2 times 2x to the third. Well, 1/2 times 2, those two are reciprocals, and so by multiplying by the inverse, we know that we're going to end up with our identity, which is 1. 1/2 times 2 is 1, and so now we can have this equivalent function. 1 times x to the third, this is our identity. We know when multiplying by the identity, we're not going to change our outcome. And so we could rewrite this as x to the third to the 1/3. Well, nicely enough here, we know that this is cubing a number. This is taking the cubed root, which are opposites or inverse of each other. And so we know our z of v of x is actually equal to x. Well, this is great because our z of v of x is equal to x, our v of z of x is equal to x, and as we saw earlier, if v of g of x and g of f of x, are equal to x, then both f of x and g of x are inverses of each other. So nicely enough, because we were able to do composition of functions, we saw how these could be simplified, that they are equal, which shows that they are the commutative property, which means that they are inverses. All right, thank you.